Hey Global Impact students, this is Mr. Ellinger. This lesson is on linear functions in slope-intercept form. Our learning targets for this lesson, we want to be able to graph linear equations and we want to also be able to write equations of lines. Some essential understanding for you in this lesson. Moving from any point on a non-vertical line in the coordinate plane to any other point on the line, the ratio of the vertical change to the horizontal change is constant. The constant ratio describes the slope of the line. Slope can be calculated by finding the ratio of the difference in the y-coordinates to the difference in the x-coordinates for any 2 points on the line. Some background information for the lesson. Although any two-variable equation can be graphed on a coordinate grid by plotting ordered pairs, there are often more efficient ways. All ways start with identifying the general shape of the graph from its equation. We must be able to quickly identify the general shape, which will allow us to proceed to using the techniques that we learned. Okay, so consider a non-vertical line in the coordinate plane. Here we have a non-vertical line in the coordinate plane. If you move from any point on the line to any other point on the line, the ratio of the vertical change to the horizontal change is constant. That constant ratio is the slope of the line. So that's saying if you pick some random point here, some other random point here, and you calculate the vertical change and the horizontal change, that ratio is going to be constant, whether you use these 2 points or whether you pick some other point here. Okay, if you go vertical change over horizontal change, you're going to get the same ratio. Okay, so let's talk about slope. The slope of a non-vertical line through points x sub 1, y sub 1, and x sub 2, y sub 2 is the ratio of the vertical change to the corresponding horizontal change. So here's slope. We have our vertical change over horizontal change. The vertical change we refer to as the rise. The horizontal change we refer to as the run. Slope, rise over run, okay? And a lot of times when I ask students, what is slope? They will say, rise over run. Rise over run. Okay, rise over run is just one aspect. It's just a graphical aspect of slope. There is so much more to slope than just rise over run. But we have a formula to calculate slope when we're looking at a graph. Okay, what we're going to do is we're going to subtract our y-coordinates and we're going to subtract our x-coordinates. Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Remember the subscripts help us keep the order of the numbers that we put in here. Whatever y-coordinate you choose first, you have to choose the x-coordinate from that same point first in your subtractions, because remember, the order that we subtract matters. So here are some different options for slopes. We can have a positive sloping line. The line rises from left to right. So as you scan the graph from left to right, if the line's going up, say it's positive slope. If the line's going down from left to right, then we say it has a negative slope. This is a zero slope, okay? Remember, slope is rise over run. There is no rise. So the top of your slope fraction in this case would be a 0. And anytime you have 0 in the top of a fraction, you get 0. So this is a zero slope. When we have a vertical line, we have undefined slope. And the reason is, when we look at our slope formula, okay, if I pick two x values on this line, they're going to be the same. And when I subtract them, I'm going to get a 0 in the denominator, and that means undefined. It's an undefined value. So we call that an undefined slope. So a function whose graph is a line is called a linear function. We can represent a linear function with a linear equation, such as y equals 6x minus 4. But we could also very easily write f of x equals 6x minus 4. They would be the same thing. A solution of a linear equation is any ordered pair xy that makes the equation true. A special form of a linear equation is called slope-intercept form. An intercept of a line is a point where a line crosses an axis. The y-intercept of a non-vertical line is the point at which the line crosses the y-axis. The x-intercept of a non-horizontal line is the point at which the line crosses the x-axis. And here you see a graph. Here's our y-axis, here's our x-axis. This red line crosses the x-axis here. That's the x-intercept. So here's our y-intercept where the red line crosses the y-axis. We call that a y-intercept. All right, so one form of a linear equation or function is what's called slope-intercept form. The slope-intercept form of a line is y equals mx plus b, where m is the slope of the line and 0 comma b is the y-intercept. But in the equation, this number here is our y-intercept. Slope-intercept form allows us to draw quick graphs because we can just look at the equation and we can know the slope right away and we know the y-intercept, okay? It's not always going to be a plus sign here. If it says plus 2, that means the y-intercept is positive 2. If it says minus 2, then the y-intercept is negative 2. So what is an equation of each line? Well, in A, it's telling us m equals 6, y-intercept is 0, 5. So if we have our slope-intercept form, we just plug in the numbers. And there is our equation. Okay, very simple. In part B, we have to work a little bit here. So here's the y-axis. Here is my y-intercept. I see that the graph is scaled. Each one of these is 1. So here's the origin. So this is -1, -2, -3. So from the graph, I know my y-intercept is -3. Now I need to calculate the slope. Well, here I have a point, a distinct point that I know the coordinates of, and here I have another distinct point that I know the coordinates of. And how do I know that? Well, look at my grid lines. This point has the coordinates -2, -2. This point is our, like I said, our y-intercept, so it's 0, -3. But if I want to calculate the slope, general rule, this is what I do. I always go left to right across my graph. So from this point to this point, my vertical change, I've got to go down 1 unit and I've got to go over 2 units. So if the vertical change is down, that means it's -1. And I'm going to the right 2. Okay, so I let the vertical change, the rise, dictate whether I'm positive or negative in my slope. And I'm always going to run to the right if I can. Okay, now there might be times, depending on how the graph is presented to me, that I may not be able to do it this way, but if I can, this is how I do it. And when I have -1 in the numerator of the fraction, I can pull the negative out front of the fraction like this, so the slope is -1/2. Now I want to write my equation, so my slope is -1/2. And my intercept is -3, so my equation is y equals -1/2 x minus 3. Part C here, using the graph from part B, do you get a different equation if you use -6, 0? So over here, they're saying use this point instead of this point. So I'm going to use this point, and I'm going to use this point. So they want me to use the x-intercept, and they want me to use the y-intercept. Well, I know my y-intercept is still -3. That's not going to change. My slope, so going from this point down to this point, I'm going to go down, and then I'm going to go over. Now, remember, we're doing a right triangle thing here. We're going straight down, vertical, and then we're going straight across. Well, I go down 1, 2, 3 units. So that's a -3 vertical change. And then I'm going to go over 1, 2, 3, 4, 5, 6. 6 units. So my slope is -3 over 6. So it's -1/2 when I reduce. So I get a y equals -1/2 x minus 3 equation, same equation. So that proves a very strong point. No matter what 2 points you pick on a line, you will always get the same slope. You will always have the same y-intercept, and you will always have the same equation. Okay, so one thing that we need to be able to do, because slope-intercept form is so useful, it is the preferred method of choice. Anytime that we want to write an equation, sometimes they're not given to us in slope-intercept form, and depending on the work that we need to do, a lot of times we want to just go ahead and write this thing in slope-intercept form. So here we have an equation, -3/4 x plus 1/2 y equals -1. We want to write this in slope-intercept form. So what we're going to do, remember, we're going to solve for y. We're going to isolate y. So the first step is to add 3/4 x to the other side, because it's negative 3/4 x on this side, so we're going to add it to the other side. So we have negative 1/2 y equals 3/4 x minus 1. We're going to multiply both sides by 2, because we want to get rid of the 1/2. So when we multiply both sides by 2, we get y equals 3/2 x minus 2. This is in slope-intercept form. The slope of my line is 3/2, and my y-intercept is negative 2. B is negative 2, but it's more appropriate to say that the y-intercept is a point. So it's appropriate to say that the y-intercept is 0, negative 2, not just say the y-intercept is negative 2. So go ahead and pause your video here just a second and go ahead and try this. What is the graph of 4x minus 7y? Before you graph it, let's go ahead and put it in slope-intercept form. So go ahead and do that. Pause and then restart it, and I'll have your solution. Okay, so when I solve this for y, I get y equals 4/7 x minus 2. So that tells me that I have a slope of 4/7, and I have a y-intercept of 0, negative 2. So I start off by plotting the y-intercept 0, negative 2, and then from there I use my slope to go up 4 units, and then I go over 7 units. It's always a good idea, because if you're drawing a freehand graph, it's always a good idea to just go ahead and label the points that you use, okay? This point here that I used is 7, 2, okay? And this is 0, negative 2. All right, and I do my best to draw a straight line through my 2 points. You should have a straight edge, so it's always a good idea to just go ahead and use a straight edge. Draw your lines all the way across the page and put arrows on the end of your lines, because lines do go to infinity in 2 directions. So let's draw them as such. So why is slope-intercept form of a linear equation so important? Just to kind of summarize things here. Number one, it's the easiest form to use. Slope and y-intercept are easily obtainable, which allows us to produce graphs very quickly. Also, slope-intercept form is linear function form. Recall that we can use y and f of x interchangeably, assuming that the equation we are working with is a function and it is written as such. Have a good day, folks.